So next paper, please. Context-aware and voice interactive search. Presented by?
I am co-author.
Ah, okay.
Yes. Okay, good afternoon, gentlemen. My name is Phan Đăng Hưng. Our research group came from the Vietnamese Institution of Information Technology and the Vietnam Aviation Institution. And now it is my honor here to give a talk about our research, the context-aware and the voice interactive search. My presentation contains four main sections. The first is the introduction. In two letters section, I will give a talk about two main techniques we apply for the speech processing in Vietnamese and for the search engine. The fourth section is the experimental. Firstly, as you know, search engine which appeared several decades ago and is a very useful tool for the user to search for the whole resource of information on the internet. And to make accuracy searching, there are several searching techniques has been developed for to help these tasks. We can see that the most popular technique is the keyword searching, and after that there are several different techniques that focus on the semantic search and the context search. And in our research, we make an effort to contribute a search engine for a specific domain, that is the aviation data. And to contribute this search engine, we face two problems. The first problem is that what technique we use to apply for the search engines, and the second problem is that how to help user to interact with the computer system. And with the first problem, we apply the advantage of the context-aware technique, and with the second problem, we apply two main speech recognition and text-to-speech function for the field of Vietnamese based on the hidden Markov model. And here is the architecture of the aviation search engine based on the context-aware. And with the input, including the voice and the state of the user, this input will be pre-processed to saving in the query log, and by the context-aware method, which focus on the query log and use some data mining technique. The result of this analyzing is the set of future queries may be related by the user. And to help the user to interact usefully with the system, we apply two main functions. Two addition functions. The first is the speech-to-text function, which allows user to control the system by the voice command, and the text-to-speech function, which allows user to hear the content of the research returned by the search engine. And in the section 2, I will give more detail about the speech recognition and text-to-speech function of Vietnamese. With the speech recognition, we use the advantage of the statistic model, hidden Markov model. And with the Vietnamese, the input text in Vietnamese will be converted to a set of phoneme in Vietnamese, and each phoneme will be statistics and represented by each appropriate 8 mm. And the number of the steps, in this example, 3 steps in 8 mm, relate directly with the characteristic of the phoneme in Vietnamese. And the hidden Markov model is one of the most popular algorithms implemented to forecast for pattern recognition problem. And to calculate the probability of maximum of the output, we use this formula. In this formula, there are two main components. The first component is the probabilities related on the characteristic of a recorded sound, and the second probability is the probability related to the language model. In another word, it is the domain problem. Like in our research, it is the aviation domain. And to implement the hidden Markov model-based speech recognition, we use the advantage of the SMM toolkit, stand for STK. There are 4 several steps to contribute an STK speech recognition system. Prepare the data, creating monophoneme in Vietnamese, calculate the 3 phones in Vietnamese, and executing and evaluating the speech recognitions. And here is the set of tools used by the STK. And the advantage of the hidden Markov model is also used for the text-to-speech system. But although it has some advantage, it remains some drawback. The bad drawback is that it has very low naturalness based on the statistical method. And to overcome this problem, we combine the hidden Markov model with the traditional unit selection speech synthesis, and we combine this approach to the hybrid approach between unit selection and hidden Markov model. For detail of this method, this process is providing in 2 main steps. The first step is evaluating cost of selected unit, and from this selected units, by this formula, we contribute a set containing 2 main units. Firstly, is the natural unit store of voice unit stored in the database, and the second unit is the SMM synthesized units. And with this set of units, in step 2, we will selecting appropriate sound units based on the cost functions. We calculate by this formula. The cost function is reflect the error rate when we concatenate 2 candidate sound input. And in section 3, I will talk about the technique we use for the search engines. But firstly, let's talk about a very common example. You can see that with the current query and with a normal search engine like the keyword search engine, the result will be very confused. As you can see that, the tiger here can be many objects like an animal, an ally system, and a golf player. And to overcome this problem, our methodology is that we focus on 2 main components. The first component is the recent query inputted by the user, and the second component is the history of searching by the whole community for the search engine. And for this example, if you focus on the recent query inputted by the user, boom, you can see that the result of this query may be related to a golf player, Tiger Woods. And the most important part of the context-aware technique is that we have to perform mining method to determine the future queries that may appear right after the current query in the search session. And the idea of the context-aware technique was developed by previous research of Huân Cao. The context-aware technique provides is based on 2 phases, the online phase and the offline phase. In the online phase, the input of the user may be analyzed and extract the concept sequence. And with the purpose of the offline phase is that based on the query of storing the history of searching by the user, it will extract the concept sequence suffix tree. And by the comparison with the concept sequence and the concept sequence suffix tree, the output of this process will be the number of the future queries may be related by the user. And here is some more detail about the context suffix tree. And with the context, with the searching in this context suffix tree, with the input that a set of previous query by the user, the result will return as a rank list from the database. Some future query may be related by the user. In this example, the Q1 is related with the Q5, the Q2 with the Q9, and the Q3 with the Q20. And although the traditional context-aware developed by Huân Cao has many advantages, it remains some disadvantages. One of its disadvantages is that to contribute the concept sequence suffix tree, they have to detect the relation, the similarity between 2 queries by the user, and they use only 1 factor, the number of URL clicked with the result returned by the query of the user. And in this result, we are storing the history of user in the query log, And to determine to allocate the similarity between two queries from the database, we use another factor, including three factors. The first is the query. Is about the term in the query. The second is about the top and result returned in each query. And the third factor is the URL clicked by the user. And here is the similarity formula to detect the similarity between two keywords. And along with that is the formula to detect the similarity with the top 50 URL results by specific query. And the similarity with the number of URL clicked by the user. And we detect, we create the formula, this formula, like this is stand for the similarity between two queries in the database. And it is the combination of three factors, the keyword, the top 50 URL, and the number of URL clicked by the user. And by experimental, we calculate these three heuristic parameters, alpha, beta, and theta, to minimize the error rate of the search engine. And along with the normal search engine, the result will be returned by only one set. And in our search engine, we group the return results by different categories. For example, with this input, like the company information about the company, the result will be returned in in several different sets. Each set contains the relation between the category. And the fourth section is some experimental. Firstly, it's about the search engines. The results of the context-aware technique applied for this research is the context-aware search engine. And in this search engine, along with the results, the system will analyze by the context-aware technique to return to subget future query may be related by the user. For example, if the user input the text like check the security at the airport, along with the results, the system will compute and subget the future query like the user can be maybe related about the security of the airline system and the airline system staff. And for the text-to-speech system, as I said before, the number of the steps in each 8mm model is reflected directly to the characteristic of each phoneme in Vietnamese. And in the experimental, we detected the number of the steps in the 8mm based on three factors, two heuristic parameters, and TS is the duration of the phoneme in Vietnamese. And by the experimental, we try to minimum the error rate of the speech recognition system by changing these two heuristic parameters C and F. And to detect the accuracy of the text-to-speech functions, we use the means opinion score methods. This method is used by an online survey made by user who will hear the voice with different methods and detect by marking the voice. And the result of the experimental with the Morse matrix test returns that with the hybrid synthesis test, it is the combination of unit selection and 8mm. The hybrid method has a higher similarity, truthfully and natural needs than the traditional 8mm based synthesis test. And in the end of my presentation, I want to show some screenshot of our application. Here is the speech recognition function for Vietnamese. And each voice query will be sent to the server run HTK speech recognition on the Ubuntu platform. Actually, it's not have sound here. And here is the voice will be sent to server. And here's the research about the structure of the airplane. And here, if we have a voice, if we have a sound here, we can hear the voice of the hybrid methods. in the Southern Voice.
Maybe we haven't.
And thank you for your attention.
Thank
and,
you.
Now please don't hesitate to ask a question.
Thank you for your presentation. Have you any question?
Yes, I have a question. Maybe
Yes.
you can start.
Please, not problem.
Please.
Okay,
Please.
thank you for your presentation. I have a question about the dataset. How do you close the user logs? How do you collect the user log?
Yes, well, our research group have a collaboration with the Vietnam Airlines, and we collect the data from the whole document about the airline system in Vietnamese.
So that means the airline system, they have a search engine,
Yes.
and the user log into the search engine and they search.
Yes.
Really? Okay. Are you going to public that dataset?
Yes, we will publish this dataset soon.
Okay, thank you.
Thank you.
So,
Yes, please ask your
I'm
question.
prepared. Yeah. I would like to ask you. I'm not familiar of speech recognition, but are you sure that there is so many differences in Vietnamese language to other language? Because you didn't show us any comparison of speech recognition.
Oh,
because
yes.
the
Yeah.
Czech Republic in the University of Brno are, I think, the leaders of speech recognition. So I know that they are really good. So I would like to ask if you compared with other algorithms or other products, how is your application better than other? And is
Yes.
yeah.
Actually, HMM methods is well developed methods
Yeah.
that apply for another language like Japanese and English.
Yeah.
And but in Vietnamese, has been developed in recent years.
Okay.
Yeah. And with the research, we will get the lower accuracy than the popular language like English and Japanese. And in the future, maybe we can combine these HMM methods for another method like the deep learning methods. And the second problem, the second solution is that we have to make deeper research about the characteristic of Vietnamese phoneme.
Yes. Okay. I think that's. I have heard, but I think it's
Thank
okay.
you for your question. Thank you for your answer. And thank you for your presentation. So, next paper, please. What should I comment? Recommending post for commenting? It's a good title.
So actually,